Alright class, today we're going to be learning how to graph the sine function. Now, you should know a little bit about sine already. In trigonometry you learned how if you have a right triangle and you have an angle x here, the sine of the angle x is going to be equal to b over h if we have b the opposite side and h the hypotenuse. Now that's kind of one-dimensional because x is only in a triangle allowed to be between 0 and 90 degrees, given that one of the angles is already 90 degrees. But the sine of x is going to have a domain for x negative infinity to infinity. All real numbers can be fit in there. So we have to see how we get values for the sine of x given values of x that are outside of 0 to 90 degrees. So let's look at in an xy plane, we got the unit circle here. Now if you were to draw any angle, let's say we go all the way here, this angle is going to be, let's just say that it's measured 210 degrees. So x is 210 degrees. Now how to find the sine from that is you just drop a little perpendicular down to the x-axis. And in here, the angle between diagonal and the x-axis, we'll call it y, is going to be the angle that we're looking for in order to find the sine of x. As a general rule of thumb, if you can find that y, then the sine of y will be equal to the absolute value of the sine of x. Now I say the absolute value of the sine of x because sine doesn't always have to be just positive. It can be negative. Now if we look at an xy plane, we got 4 quadrants, and we're just going to label these A, S, T, C. Now this acronym will tell us when the sign is positive. And the simple acronym to remember it is, all students take calculus. True enough, right? Now if I was to tell you that, given these letters, that they stand for trig functions, showing where they're positive, given a certain angle as to what quadrant it falls into, what do you think the S is going to be for? It's going to be for sine, the T for tangent, and the C for cosine, and the A is for all. So if we have an angle in the first quadrant here, or between 0 and 90 degrees, all 3 trig functions, sine, tangent, and cosine, are going to be measured positive. Here in the second quadrant, the sine will be positive, but the tangent and cosine will be negative. And in the third and fourth quadrants here, the sine will be negative. So coming back to our x here, saying that it's 210 degrees, it's going to fall in the third quadrant here. So the sine of x has to be negative. If we look at y, we know that it is going to be 180 less than x. So if we just subtract 180 off of 210, we get 30 degrees. So that's our measure for y. And we can easily know what the sine of 30 degrees is. We know that from our 30, 60, 90 triangles that the sine of 30 equals 1/2. And if we know that the sine of 1/2, or the sine of 30, is equal to the absolute value of the sine of x, and the sine of x is going to have to be negative, then the sine of x equals negative 1/2. So given this rule of thumb to follow, we can find the value of sine for any x value, no matter the angle measured, even going beyond 360 degrees. If we start here again from our 210 degree measured angle, and we go around another 360 degrees, we're still going to be on the same line, giving the same y value. So if we have 210 degrees plus 360, we now have a 570 degree angle. But because it has that same y value there, we know that the sine of 210 is still going to be equal to the sine of 570. So what's a rule of thumb that we can follow? If we have the sine of x, it's always going to be equal to the sine of x plus 360. And using this, we can find the sine for any angle that we want, that we're given. Now, the easiest way to go about graphing the sine function for the first time is to maybe make a table of some values that we know and expand that knowledge using what we just showed you. We can get a bigger table. So what are some values for sine of x that we know already given an x value? We already know that the sine of 30 is 1/2. Let's see what else we got. The sine of 45 we know is equal to the square root of 2 over 2. The sine of 60 equal to the square root of 3 over 2. And etc. These are the ones that we know already from 30, 60, 90 triangles and 40, 45, 45, 90 triangles. Now if we expand that knowledge, we can add 360 to these to get new angles, and also consider here we had our x value, we just subtracted 180 and we got a y value for which it was the opposite. So the sine of 30 is 1/2, the sine of 210 was negative 1/2. So let's look at an angle measure 60. If we take 60 plus 180, that'll give us 240. So we can safely assume that the sine of 240 degrees is going to be equal to negative square root of 3 over 2. And using this pattern we can continue. I've already made a table for us, and I converted all the angles into, not from degree over into radian. Because when it comes to graphing the sine function, it compresses it more, makes it easier to graph when we base off of radian measures. So given these, we can plot a few points on our graph. Let's start here. Let's just make pi here. We'll move this down. And 2 pi out here. Pi over 2 and 3 pi over 2. Just some simple points to measure. We could start, we have our table here. We know these points already, and we just use the rule of thumb to follow to get more of them. So if we start from 0, 0, pi over 6 is equal to 1/2. Pi over 4 is equal to 0.707. And we can continue on this fashion. These are just rounding here, approximations. Root 2 over 2 equal to 0.7 over 7. Root 3 over 2 equal to 0.866. Easier to graph that way. We're going to find a few points along here that seem to form a curve. Now, based off of these quick values, I just plugged in a few points right away, and we can already kind of see a shape going for it. If we just kind of trace a curve along here, along these points, we get an approximation of what our sine graph is going to look like. And we know that when you add 360 to any angle, you're going to get the same sine value for it. So what do you think is going to happen when we continue past 2 pi? If we can just take a point out here, subtract 2 pi from it, we're going to get an x value right in here. We already know this y value, so this y value is going to have to be the same over here. And so the sine function will just continue as follows. To the right, and over here off to the left if you just subtract 360. So here we have an approximation for the sine graph. A little bit easier to do on a calculator, but now that you know how it's done, you'll understand it a lot better using a calculator.